Hello everyone. Today I will show how to use embedded Rust to get values from a Rotary Encoder. I will use embedded Rust and an Arduino Uno and obviously a Rotary Encoder. Before we get started, let's talk about Rotary Encoders. If you search Rotary Encoder in Google Images, you get quite a few pictures and some good both documentation and videos. I would encourage you to go through those. I will just give a brief overview on how they work using one of the first pictures that Google shows me. This is a rotary encoder. Basically, you have two outputs that are named clock and data. There's also a button I won't care about. Generally, what you do, you can keep rotating this encoder, and there are bits connected to either ground or power. So this means as soon as this connected part to power, hits one of the pins, that pin will go high. So if I look at this, if I turn towards the right, let's say blue would be, I will call it the clock. If I turn this towards the right, blue will turn high, but green will stay low. And if I keep turning, at some point, green will go high again, and then blue will go down. So generally, this means that when I turn towards the right, first the line that I call clock changes, and then only the other line changes after a while later. So this means that the values are out of phase. So this is how I can detect that if I turn towards the right, and the clock value changes, I compare the two values, one is high and one is low, and if one is high and one is low, this means I just turn something towards the right. If I go the other way, this means green will go, let's say, high first, and by the time blue goes high, green is already high, so they are in phase, and this means when I turn towards the left, when my clock changes, either both values would be the same value. So this means what inside the program, what I have to do is I check when my clock changes, either it goes high or it goes low. And then if the two values of the pins are the same, this means I turned towards the left. And if they are different, like in this diagram, this means that I turned towards the right. So I know when I turn by watching the clock. So the clock changes, this means something got turned. And then I can see the direction of the turn by comparing the clock and data line. If they are the same, it's one direction. If they are different, it's another direction. So great. Let's get started and implement some code. I showed in a previous example how to get started with Arduino. Generally, you start this using this example. You do cargo generate. So I will go ahead and do that. Cargo generate, and I will call this encoder, Rotary Encoder. And I want to build it for Arduino Uno. Great. Rotary Encoder. And I open Sublime Text. This is a simple LED blinky, and I would like to read rotary encoders. If you just want to get started very quickly, if you go to the examples of AVR HAL, there is Uno pin change interrupt RS, which actually shows exactly a rotary encoder. So it shows rotary pins, and actually it drives a motor. So it does a few more things. I'll be concentrating on how this works, how rotary encoders work, and I connected pins 2 and 3 to my actual Arduino Uno right here. And I will do things a little bit differently, and I will also go through how these clocks and data and what this external interrupts mean in general. So let's go through the logic. First of all, I have two pins connected. One I call data and one I call clock. And I see a lot of code in here regarding interrupts. So what I described before is I want to detect when the clock changes. And when the clock changes, I can ask my Arduino Uno to give me an interrupt. So this means, hey, something changed, do some operation. So my goal is whenever clock goes up or down, high or low, I will have an interrupt. And the example already sets these various register values. I will show you how these come about. So first of all, I want to get a interrupt when a pin changes. So if I look at the pin change interrupt control register, if I do a search in the data sheet, it will tell me that I have three separate interrupts. One is 0, 1, and 2, not that helpful. And each of these apparently control specific interrupts. I have interrupt 23 to 16, interrupt 14 to 8, and 7 to 0. So it's not all that obvious which of these are my actual pin interrupts. So my next step would be search for the clock pin. And if I search for D2 where I connected my clock, let's go, it will tell me PD2 is actually external interrupt 0, or it's pin change interrupt 18. So at this point, I know that I need pin change interrupt 18. So going back to my previous data sheet, first of all, where does 18 fall into? I see it over here between 23 and 16. This means for me to enable a DT interrupt, I have to enable the second bit, well, the third bit, I guess, bit 2, from PC ICR. And then if I keep going, this documentation also tells me that I want to have to enable the interrupts individually in the mask2 register. So let's search for PC mask2. And over here, it will say this starts at 16, 17, 18. So amazingly enough, also, this is symmetrical. So I need to enable the third bit, or bit 2, in this mask register to enable interrupt 18. And interrupt 18 corresponds for me detecting the clock changes. So this explains how all these values are come to. So it says clock is pin D2. And then if I go into how do I enable those interrupts, the example shows me that it says pin change interrupt control register is set, and the third bit is set. And then in mask2, the third bit in mask2 is set. So we're going to do the same thing. So let me go through this, and I will delete most of the things. And at this point, what I need to set up a little bit of pins. And I also want to have some communication. So let's do something like this. I'll have some println, and also want some output, so I see that things are actually working. So if I go through these things, I created a serial so I can write something to the console, and I know I have a clock and the data. The clock is D2 and the data is D3. So the next step would be for me to change the interrupt registers, and I'll say I want to have interrupts. And finally, I will want to enable interrupts globally. I think this is unsafe because after this, interrupts can actually happen. And I have typos here. So whenever my pin changes, at this point, I will have an interrupt called. The way interrupts work is that there is an interrupt vector table. So the MCU will look at a list of functions that should be called whenever an interrupt occurs. So I have to put something in the interrupt table to say that, hey, this is what the code that I want you to run when an interrupt happens. And the name is very particular because the compiler and the linker will use this name. So what I will say is I want to use the interrupt for my Arduino Uno, and I don't care about the linter telling me that this is a non-standard name because I know it's a non-standard name. This is exactly the name that I have to use for interrupts. So I'll say interrupt code here. So I compile things. Hopefully they will compile. Let's do a cargo run and see if I actually get this tick, tick, tick. Probably not yet because it doesn't like me. Oh, I don't have AVR device. I don't have imports. So let's go into cargo.toml and add an AVR device entry. The way I get it, by the way, let's see if I have cargo 3. I check AVR device. This is where the 0.3.2 comes from. So basically my dependencies depend on it, but I don't depend on it directly. So this is why I cannot call things from it. So let's see if this made the compiler happy. Not yet. I need to add a specific feature to support interrupts. That's okay. And oh, I didn't write where to write. I have to write into serial. So I write into serial tick. I have some warnings, but that's fine. It takes a while for it to flash, and now it will keep on saying tick, tick, tick every 1 second. So I know my code works. I have a few unused variables. I will fix that later. That's fine. Now let's talk about how can I detect these pin changes. So the way I would imagine is that I want some sort of struct Rotary Encoder, And the rotary encoder would have a clock that is some type. I'll figure that out later. And it will have data, which is of the same type. And I will also want to know if I turned it left or right whenever an interrupt occurs. So this turn will be some option of direction, let's say. I think direction is too general. Maybe I will get conflict with something else. So I will call it turn. First of all, let's define turn. And turn will be either left or right. Perfect. And now let's figure out what types I would have here. Generally, I would want some sort of a pin. And I won't care what pin the clock is and what type of pin the data is. So I'll just say I want some sort of an input. And the input will be floating, because the rotary encoder actually gives me the values that are either high or low. I don't have to pull the pin myself. Let's see. It doesn't like, probably doesn't like pin or something like that. Okay. It says unused imports because I use semicolon instead of comma, and it says then code. Perfect. So I have my struct rotary encoder, and now I would like to create it, so I will implement it. And the way I implement it, I want to create a new rotary encoder, and I will create it saying if you give me a clock and the data pin, I will just create a new object, and it says it didn't turn yet. And then the other thing is I would like to implement the interrupt. So if somebody notifies me that the clock has changed, I would like to compute a turn value. So I will implement a method that's called notify turned, and it will figure out if the clock and the data are they at the same level. If yes, I will say I turn towards the right. If they are different, I say I turn towards the left. And then the other thing that I want to do is inside main, I want to know whether I turned left or right. So I will have a method that says give me the current turn value. So I will call it, let's say, check turn. And in this case, it will return my optional turn value. And what it does in practice, it takes the current value and replaces it with none. So this means I take the current turn, which was computed during the interrupt, and I return it. So this is my rotary encoder. In theory, it should work. In practice, I actually have to store some sort of static variable that is my encoder. And this will be some sort of rotary encoder. The trouble that I have here is that the rotary encoder is not available all the time. So it will be available after I create my clock and data pins. I will be able to create a rotary encoder here. So this means that when the program starts up, I won't have a rotary encoder. This has to be an option of a rotary encoder. Because it will start off as none, and then I have to create it. The other thing that I have to do is that this value has to be mutable. Right now, values will be immutable, and I need to set it up during main. So my next part would be this has to be a ref cell of an option, which means it's something I can change. So the ref cell will be equal. I will initialize it with none. The final bit that I need to ensure is interrupts and code will run in theory, like you can consider as kind of different threads. Like you shouldn't be able to access one while another one is processing the data. So what I will do here is I will make sure that this is protected by a mutex. So let's say this is a mutex of a ref cell of an option of a rotary encoder. So this is really messy, but hopefully it will be okay. So my logic is as follows. I have a mutex because this value has to be protected and not accessed at the same time by two different threads. Then I have to be able to change the value. So it's a reference cell. And then I have to have an optional rotary encoder here because main creates the rotary encoder and then the interrupt uses it. So let's first implement the interrupt. In order for me to use a mutex, I will need to make sure that all interrupts are disabled. This is how the mutex API works. So I will do AVR device interrupt free, and the interrupt free gives me context. And at this point, maybe I know the mutex will have been initialized with the rotary encoder, but it's probably good practice for me to check. So if I say if let some encoder, let's see if the encoder is the same as encoder borrow. So at this point I have the ref cell, and I have to get the mutable value, and I have to get the option value. So this should give me an encoder that is mutable. So at this point encoder should be a mutable encoder. It says unknown, but once I save it, it should be fine. I think this is how I called. Yep. So within the interrupts, I notify when the encoder has been changed. Let's save it and see if it compiles. This is messy code, so may take a while. It doesn't know what mutex is. I will have to import it. I think it's from AVR device. So I'll type it in here. Let's see what other complaints I have. It doesn't know what a ref cell is. Let's see if I can auto import. It's from core, like it says use core cell ref cell. So I'll just click enter. See any other complaints. No other complaints except that I don't use the other methods. This should be fine. So I have to create a rotary encoder here. And the way I create it is I just place it into my struct. So I say AVR device. And in here, I want to change the encoder. See, I don't use the result here. Let's make the compiler happy here as well. So what I will do is at startup, I will say create the encoder, then I enable interrupts, and I expect that interrupts will make the encoder mark a turn left or right. I will compile now. It compiles, perfect. And now inside my loop, let's say I would like to read the value of the encoder, and I would like to grab its turn value. So the way I write the turn value, remember I have a mutex there, so I have to do interrupt free. And what I will do, I will check if I have encoder, I guess more copy and paste. In theory, I already know that the encoder is set, so I could just unwrap it. And then once I have a turn, I would like to print it out. So let's see, I know I have a turn, so let's say if I turn towards the right, I will write, I'll write it out. And without a delay, I hope I can busy loop. So at this point, I don't have equality implemented. That's fine. I can use some sort of derive. Let's see, partial equality. This seems to work. At this point, nothing is shown. I expect that if I turn the rotary encoder, I should start seeing values. So I turn towards the right. Now it turns towards the left as well. You can also see that sometimes it either bounces or I am not that accurate. Like when I turn, I'm not that accurate. But generally, this seems okay. And the worst case, if I have an extra left or right, but I use this for something like volume control, it's reliable enough. You could implement your own debouncer if you wanted, or another thing that you could do, you could say that maybe my main code takes a while to do all sorts of computations. So rather than me getting a value that is left or right, maybe I want to create a counter. So when I can put here and U32 and I say I turned it this many times, and then the notify turned has to increase the turn right or increase the turn left or maybe move left to right or things like that. So you can make more complex code that actually tracks a rotary encoder, but as a starter project, this should be sufficient. So I hope this was interesting or helpful or both. And that was it. Have a great day. Thanks.